Differentiate the following function with respect to x. The function is x to the power x minus 2 to the power sin x. Let y equals to x to the power x minus 2 to the power sin x. Suppose x to the power x equals to t. Take natural logarithm on both the sides, hence we get log t equals to x log x. Now differentiate with respect to x on both the sides, hence we get d by dx of log t. D by dx of log t can be solved using the chain rule, which is written here as d by dt of log t into dt by dx equals to d by dx of x log x. This is a product of two functions, hence we can apply product rule. Hence we get d by dx of x log x as log x plus 1. Hence dt by dx equals to t into log x plus 1, where t is equals to x to the power x. Hence dt by dx equals to x to the power x into log x plus 1. Similarly, let's suppose k equals to 2 to the power sin x. Hence, taking natural logarithm on both the sides, we get log k equals to sin x log 2. Hence, taking differentiation on both the sides, we get d by dx of log k equals to d by dx of sin x log 2. D by dx of log k can be evaluated by using chain rule as d by dk of log k into dk by dx, which is 1 by k dk by dx equals to d by dx of sin x is cos x, and since log 2 is a constant, so cross multiplying k on the other side, we get dk by dx equals to k into cos x log 2. Replacing the value of k as 2 to the power sin x, we get dk by dx equals to 2 to the power sin x into cos x log 2. Now, since we supposed y equals to x to the power x is t and sin 2 to the power sin x is k, so y is equals to t to the power minus k. Hence, differentiating with respect to x on both the sides, we get dy by dx equals to dt by dx minus dk by dx. Replacing the values of dt by dx and dk by dx in this equation, we get dy by dx equals to x to the power x into log x plus 1 minus 2 to the power sin x into cos x log 2, which is the final answer. Thank you.